So let's just get started.
Clicker doesn't work. So what we're going to be talking about today is Diane is going to introduce what Kubernetes and OpenShift are. I'm going to be talking about how Puppet fits into that ecosystem. And then we're going to talk about what the overall benefit is, what the business rationale is for using these tools together in the sort of opinionated workflow we're describing. I'll also be doing a demo of pulling these tools together to show you what it's actually like to use them. So I find my job is running infrastructure. Or at least that's how I thought about it for a long time, because so much of my everyday work was running infrastructure. But I've come to realize my job is actually to put useful applications in front of people. And the reason that I started to feel like it's my job to build infrastructure is just because I got distracted by how much time it takes to redo the same steps over and over again. So I'll give you an example here, is when in the last year and a half, I've moved Puppet.com from Linode to AWS, and I moved PuppetForge from Google Compute to AWS. And before we moved them, they didn't have any shared code. They didn't have any shared patterns. They had totally separate paths for how they were managed, deployed, all of that. And so we wanted one common approach to running those so that we wouldn't have duplicate effort. And we went through all of that work, and it took a huge amount of effort because we had to set up load balancers and backups and monitoring and metrics and all the usual things that I'm sure you've all done too. And after spending that much time getting a Drupal site and a Sinatra site moved, I just don't want to do that again. That's dumb, right? Like, we shouldn't have to put a year and a half into putting a relatively straightforward set of applications in front of people. And I also don't want to be responsible for maintaining those standards. So what I find distracting from sort of the core goal of putting useful software in front of people is that we redo these same basic patterns, and we can't typically reuse a whole lot of the work that we did. Even when we're using Puppet, it takes an inordinate amount of time. As a result, developers trying to put stuff into production have a huge amount of friction. If part of getting an application into production is, I hope I know someone in ops, and I hope that I can convince them to support my thing, and there's a lot of confusion around what steps are needed to get into production, that's just an often insurmountable barrier. And so for solving especially the smaller problems, a lot of developers are going to say, I could solve this problem with a little Sinatra app, but it's too much work to get it into production, so I'm just not going to bother. Another source of friction that we've had in the past has been the mismatch between a declarative language like Puppet and the underlying operating system that is fundamentally imperative. So if I want to go and ensure a service is running in a regular Linux, Puppet can make it look declarative, but the actual OS isn't. And the last thing that I think we waste as a profession, that we waste a huge amount of time on, is us making decisions that computers are fundamentally better at. So if you are all making decisions about we should run X application on Y server because it has enough memory and this other box is most of the way full, that's work scheduling, and that's something that a computer can fundamentally do enormously better than any of us can, and much faster. So the time we spend on those kinds of things comes out of doing useful things that actually solve problems for the company. When we spend time doing things the computer could be doing, we're basically we're making ourselves less useful individually and as a profession. We're spending our time on integration work that in a lot of cases doesn't feel like it ought to need to happen. Our hardware gets underutilized. We end up spending so much time thinking about it as an infrastructure problem rather than thinking about applications people want that useful tools don't get deployed. How many of you have a backlog of things people in your company want to deploy but you haven't had time to?
There's a lot of hands.
There's a lot of hands and a couple of lazy people who aren't raising their hands. We've all got those lists, right? So, and the kicker is then we do all this work to build bespoke infrastructure for every one of these applications we roll out, and it's so fragile. I'll bet every one of you who's on call has gotten paged, SSH'd into a box. You had to wake up to SSH into something and start a service again. And that's what we're doing instead of deploying useful things. So that's why I'm so passionate about Kubernetes, because I came in after a year and a half of reinventing these same patterns, and I'm just at a point where never again, I will not spend months and months and months getting one application rolled out just so. I want a way to do it across the board. I'll pass it off to Diane to go into some depth.
So enter Kubernetes. And so show of hands, how many Kubernetes aware people? All right. And how many of you have deployed Kubernetes? Yeah, a few of you. So this is really a new world order that we're coming into. And what we're also seeing is that the CIOs, and this is a great quote from one of the Barclays analysts that just came out the other day, that really what our focus is on these days is no longer at the infrastructure level. We are now playing in a Docker containerized world. And what Kubernetes brings is that cluster management, scaling, deployment, and management layer for containers or Docker containers. So that's really, you don't have to justify using Kubernetes or another layer because basically Kubernetes and OpenShift run on anything, from bare metal to Google to OpenStack. And what we're trying to do with OpenShift and what we've done over the past 3.5 years is build out the developer-centric workflows on top of Kubernetes, embedding them. We are the second largest contributor to the Kubernetes project, Red Hat is. We've put a lot of our engineering resources from OpenShift to work directly on Kubernetes. So in some ways, we are Kubernetes. We consider ourselves the enterprise-ready Kubernetes for developers, because Kubernetes in and of itself manages those containers, but we are the people that bring all the application awareness to Kubernetes. And so that's really what, if you leave here anything today, those two pieces together are what make the New World Order quite a nice place to do. So the infrastructure that we bring on top of is we're all using containers for efficiency these days, and we've all moved that, or at least your developers are. And what we're trying to do for developers is hide and abstract away the infrastructure and make sure that those abstractions are specific to app developers. And so we have a tool, CLI called OC. It is a wrapper around kubectl. So those tools are there for the developers to use to put there. And what we've really tried, and we have, I think, succeeded very nicely, is to make sure that if you deploy OpenShift and Kubernetes on anything, you can also put it on other clouds. So anybody who's got a cloud infrastructure. So it's totally taking away the worry from the developer's perspective for worrying about what's happening underneath, just to what Daniel was saying. So the other part of the puzzle is that we're really trying to give you all the tools, whether it's any tool that you can compose and create an image with, plus some of the tools that we have added to the OpenShift origin repo, like source to image, to help build enterprise strength and secure images to use. And basically, we've taken all of the lessons that we learned from 3.5 years hosting a public POS. How many of you knew that Red Hat had a cloud? Yeah, a couple of you. How many have used OpenShift Online? A couple of you. So what we do, and I come at it from the community perspective. So all of that feedback and everything about the developer workflows that we learned from having over 2.5 million applications deployed on OpenShift Online gets fed into the open source project. So we have a lot of experience with that. We've got some great integrations with Jenkins and others. So all of that stuff is very developer-centric. It's a very config-driven approach to deploying these images, and we'll talk a little bit about that in the demo and show that. So how is OpenShift different than Kubernetes? You might ask, why can't I just deploy Kubernetes? And basically, what we're trying to do is secure it and make it multi-tenant and be able to deploy it on any cloud. It's really got all the workflows in it already for team software deployment, and you're able to create and deploy an application. So go from your source code in GitHub, create the image, deploy it, and scale it in just a few minutes from either the API, via the API, via the web console, or from any IDE. And we're trying and ensuring that you can deploy not just your 12-factor apps, but some of your monolithic legacy apps can get containerized and make that work all together, and trying to make that as simple and easy for developers to use as possible. So we really are, when we say we're OpenShift, we really are talking about working very closely with the Kubernetes community. We want to make Kubernetes the best place in the world for you to run your applications, and make sure that we provide all of the tool sets, whether it's Visual Studio.net support for deploying applications, which we have now with a partner called Click to Cloud, to make sure that those applications can run anywhere so you're not tied to any one infrastructure provider, and then put the extra resources. And we'll talk a little bit about that, like persistent data and other things we love. So from a 1,000-foot view, what we have is a very interesting new vocabulary, and I think that's really what I'm trying to set the stage here with, so that when we do the demo, you understand the pieces and the parts that Daniel is going to show you how to deploy with Puppet. And at a very marketing kind of spiel, that we go at Red Hat from the kernel layer, from the SE Linux support, all the way up to your application. So now with Red Hat, we have a piece of every part of the stack available to you that's supported, which I think is there. So I've said that we run on any infrastructure. We run on anything from your bare metal, which we've just done some amazing tests on. There'll be a blog post out. We're using the CNCFIOs, or the Cloud Native Foundation's cluster on Intel hardware. We run on Google. We have an offering called OpenShift Dedicated. That is our managed hosted offering that is doing some amazing things directly on Google, which you can hear a little bit more later in Kelsey's talk. We've been running for years on AWS, on Azure, on any vSphere, any virtualization. So we really have you covered. And so from an ops point of view, those applications no longer have to worry about that. So a little bit of vocabulary. The nodes, which is a new thing, is where all of the RHEL instances of RHEL where the apps will run. So that's what we're orchestrating. That's what the inside of those nodes, you'll have the container images. You'll have something called a pod, which is a group of containers, and we manage that through a Kubernetes mechanism called labeling. So all of that works very nicely inside of that. The master, I made a reference to that. With the master is making sure and managing the health and the scaling of the nodes. So it is really the thing that's driving and orchestrating all of the nodes. It knows where everything is. It knows what's going down. So we make sure that we also have an integrated registry for Docker images that's part of OpenShift so that you can manage that. Yeah, so when we talk about OpenShift or Kubernetes, you can definitely, you'll hear us talk a lot more about pods than we do talk about containers, because we care about them in the sense of there's a pod and that's all of the services for the applications. So the other thing that we've done that's different, I think, than a lot of other people who are putting out Kubernetes-based stuff is we've kind of solved for applications living and breathing in OpenShift, the persistent storage. So we do have a data store that we use Gluster and Ceph or whatever you'd like to use, and we've got that so if you have an app that needs to be stateful, that needs to know about its data store, that's built in as a service into OpenShift today. So that's quite a nice feature. There's also, oops, did I touch the button? There we go. I slid my fingers across the map. There's also a routing layer that's built in. You can hook it up to your other load balancers and that, but we use HA proxy. And all of this, from a developer's perspective, is available through a web UI. If you download on OpenShift.org our all-in-one Vagrant image, you can boot it up, and it will boot up right into a very nice web UI that's easy to do. But we also have a CLI. We're integrated into a whole lot of IDEs. I mentioned Visual Studio earlier, and you can also integrate it at the API level. So those are some of the basics, and I think we're going to go, and now we're going to see how you take that and deploy it using Puppet. So Daniel, take it back.
So to put this in some context, we've got in this new way of doing things, at the bottom layer, we've got our container images, Docker. We've got, and that functions to make applications all have approximately the same shape. We've got Kubernetes on top of that, which normalizes how those things are operationalized. And then OpenShift on top of that, which provides these developer workflows so that as operations or IT people, you don't have to do the sort of inventing workflows and tooling to make that usable by your developers. And so if you're a developer and you're just trying to push new stuff into that stack, that's a great world to be in, because you've completely abstracted away the underlying hardware and you've normalized how things are done across all applications. But if you're an operations person, you have concerns about when you want to operationalize something, you need to be able to manage change. And so Puppet has a real clear role because you want to model that configuration. Is configuration modeling a term that that makes sense to people? Excellent. I have a slide for this. So we're going to talk about how the furnace in your house works. So if you imagine managing the furnace in your house with an imperative layer, that would be something like a light switch. You're feeling cold, so you flip it on. It heats the house for a while, you feel warm enough, you flip it off. Cool. None of us do that. We have a declarative interface. It's called a thermostat. You dial it in to 68 degrees. When it's below that, it talks to the imperative layer on your behalf. You hear a little click, and it turns on. When it gets to the temperature, you hear another click, and it turns off. It handles the imperative layer for you. But we're actually not happy with that either, because let's say I want to express logic along the lines of, when I'm at home, I want it to be 70. And when I'm not at home, I want it to be 65 to save power. There's no setting on my thermostat for that because it's a different kind of concept. It's logic, not a declarative setting. What you need is some way to express that logic. And in your home, that might be something like a Nest. And the Nest has a software model that expresses that logic based on inputs you've given it about, say, your schedule or sensors that know when you're home or that kind of thing. And this is the same thing that Puppet has traditionally done for infrastructure. The imperative layer is the commands that you would run by yourself, right? So you would start an Apache service. You don't want to have to start and stop that yourself, so you need a declarative layer. In Puppet, that's the type and provider model, and type and providers in Puppet fundamentally provide a declarative interface to an underlying imperative operating system. If you have some, I don't know, an EL6 box, it doesn't natively have a declarative interface for doing most things. So Puppet has the type and provider layer, and you can tell the type and provider what state you want, and then it goes and translates that into the appropriate imperative commands for whatever the underlying infrastructure is. But that's not good enough. If you just had types and providers, Puppet would be, you write a catalog, not a manifest. You write a catalog. The catalog gets fed into your types and providers, and that's the state you get. What makes Puppet useful is the ability to build a model in the manifest. You're expressing your logic about what the desired state is under different conditions, whether that's the difference between something being in development stage or prod, different Solaris versus Linux, web server versus database server. There's the desired state changes based on the inputs to the model. And what's really cool about the Kubernetes model, and I keep saying Kubernetes, when I say Kubernetes, in your head, think Kubernetes or OpenShift, because it really applies to both here. What's really cool about Kubernetes in this context is that it's natively declarative. So you don't need that pretend layer where Puppet takes an imperative thing and does this messing around to make it look like it's actually declarative. When you use these together, you can focus on the modeling aspect. And that's what Puppet brings to the table. So in this stack, you've got your imperative layer where a Docker container is the imperative part. You say, Docker, go run Nginx right now. And to avoid needing to do that, you can tell Kubernetes, I want an Nginx pod with 2 containers to be running, and it just makes sure that that's happening. If a node dies, it'll start that back up on another system, and it handles that, very much like the thermostat. And for the developers, that's often good enough. They may not need a modeling layer on top, because they're just changing things quickly, and they're trying to get something into production. And they're the ones who want to be telling the system what its desired state is. And so OpenShift at that point makes it really easy for them to tell the system what its desired state is. But if you want to be able to express logic to change that desired state under certain circumstances, you need a model on top of that layer. So what are we modeling? Since Puppet is a common modeling layer across traditional infrastructure, networking devices, container platforms, we can model all of it through. We can model the underlying operating system the way you already all probably use Puppet. We can model the container contents the way you saw in the keynote this morning, and that I'll demo again. And you can model Kubernetes and OpenShift resources. And because Puppet already knows about your existing infrastructure, if you want to integrate these things, you kind of get that for free. So let's say you have this existing infrastructure, and you want your containerized infrastructure to be able to to discover parts of your existing infrastructure. Maybe they should be sending metrics to your existing metrics infrastructure directly. You might use Puppet to create an external service in Kubernetes so that then the Kubernetes-based services can use native cluster service discovery to find that, even though it's not actually running in there. And because Puppet is managing and modeling both of those, it has the awareness so that you can stitch that together without doing some kind of terrible one-off hack for just that problem. I won't spend a whole lot of time talking about this, but I've seen a trend in this ecosystem to go and write what amount to shell scripts. And so you all, who thinks running infrastructure based on shell scripts is a great way to run infrastructure? You wouldn't be here, right? The people who raise their hands aren't here. But anything that's procedural is fundamentally the same thing. So any kind of tool that you look at where that's basically structured as run this thing, run this imperative command, then run this other imperative command, and then if this thing is true, run yet another imperative command, that amounts to the same thing. And it amounts to the same thing because what it does is it forces you to build the model in your head about what the state of that system is in order to understand what that script does. So I'll show you a quick demo of what this looks like when you do it in a pure Puppet workflow. Can you all read that? Okay, so we're going to do two things. The first thing we're going to do is we're going to build a container. I'll be fairly quick about it because you all presumably saw the demo this morning. So we have this manifest for the container that's pretty straightforward. There's an Nginx class, there's a vhost resource, there's an index.html file. This should look pretty familiar to anybody who uses Puppet. It's immediately, I think, understandable what's in this container. So we're going to update the container contents just a little. Hello Docker, hello Puppet, hello OpenShift. And we're going to rebuild this. So you can see it is applying that manifest. And that'll, depending on how fast the Wi-Fi is here, this may take a minute. Yeah, it should be fairly quick. While that's building, any questions midstream? Nothing? I've explained everything.
How does it know what manifest is?
I think that it just uses the init manifest if you're doing it locally. I'm not actually sure. I'm not sure how that works. I haven't done, so the demo this morning used the workflow that's integrated with Puppet Server. I'm just doing the Puppet apply, basically, the local developer sort of workflow to show the rough shape of it. And I haven't done that workflow, so I'm not sure. Okay, our container is done. I'm going to push this to a repository, Docker registry. And after this is done pushing, I'm going to create Kubernetes resources using Puppet. So while that's going, I'll just wait for that. No, let's do that. For God's sake.
Doing live demos is always so much fun. So if any of you want to play with this, if you go to openshift.org, there's an all-in-one Vagrant image that you can download, and it basically boots up OpenShift with Kubernetes in it. And you can start with your own Vagrant image with all of this configured and start testing it out. It's a great way to learn how to use all of this.
So Diane explained some of the basics of Kubernetes. We're going to be creating two Kubernetes resources here, a replication controller, which creates pods and keeps them running, and a service so that it's accessible. If you've looked at Kubernetes resource files at all, this should be fairly familiar. It's the same data structures in a slightly different shape. So I just did a Puppet apply. It created those resources. In a production workflow, you would probably use a workflow that's closer to what you saw demoed this morning. But for the sake of simplicity, I'm just doing a Puppet apply here. And now I'm going to switch back to OpenShift. I've logged into an OpenShift instance I have running in Vagrant here. And this is the Nginx service that we just created. I'm going to tell it to create a route here. OpenShift routing, by the way, is really cool. If you use straight Kubernetes and you start wondering about how you're going to manage the ingress of all these different URLs and routing those efficiently to the right place, you're probably looking basically for this. I hadn't understood why it was useful until I tried to use Kubernetes without it, and then it sort of clicked.
Yeah, so that's sort of what we say is that it's the application-centric Kubernetes. The other thing you should note about OpenShift is that if you're using OpenShift for applications, you can still come in and put just container workloads in it too. So both sides is still accessible.
So here comes up that simple page that we just defined. And if we want to modify that, it's simple. We can go back in. And we can rebuild that. That'll run again. We would push the container again, kill the pods, and when they come back up with the new image in them. If I was pushing directly into the OpenShift registry, then it could handle that part automatically, so I wouldn't need to script the killing the pods in order to trigger that refresh. So while that's running, I'm gonna go a little bit more into why adding Puppet here is particularly compelling. So I've got this second version here that is the same thing, but it's a defined type wrapped around those Puppet resources. So we started out creating just a couple of resources, and then we layered this extra abstraction on top of it. So once I've figured out more or less what I want to create, maybe I want to cookie cut these things out with slightly different parameters. And so I've wrapped a defined type around it. I've invoked one of them, and this will create it in a different namespace. So if I then go and Puppet apply that, live demos, right? At least you know it's not a video. All right, I'm just not going to troubleshoot this right now. So let's see if this is done. Okay, yeah. So we push that again. Oh man, that internet is real slow. So we'll push that again, and I don't think you guys know what this is going to look like. I don't need to go over that again. So the point of all of that is you can use Puppet end-to-end to manage these sorts of problems. You can define the whole infrastructure in Puppet, and you can use Puppet-based tooling, and this plugs into your Puppet-based tooling stack. So I've robbed Diane of her time to explain why this is useful from the business side, so I'll cut over right away.
That's okay. So just so you know, Kubernetes may be a relatively new technology in the past year, we already have a number of huge enterprise customers who are deploying this at scale in production. This is just a sampling of a few different industry sectors. One of the ways that I like to look at is, how many of you have heard of Amadeus? Ever booked a trip to one in here in Europe or anything like that? They're really being able to, because of these new workflows and because they can push out new applications, they're a travel site. So anytime there's a new application or they need to push out a new service, they can do that really rapidly across the globe, across multiple data centers, and they've been able to keep the latency time, because if you've ever been on a travel site and you need to, you'll walk away if you're on Expedia or someplace and it's not fast enough. So what Kubernetes and what OpenShift is bringing to them is the ability to be incredibly agile and make sure that they can manage and keep these systems up and live. We could talk more about that at the booth in a bit. One of the things that it does, this is just an IDC paper that just came out the other day, is if you're having trouble justifying this to your infrastructure folks or your IT guys, 3 minutes left, we'll send you the white paper and you can see how you can make the money back. One of the things that I really wanted to stress is that there's a really healthy ecosystem around this. I run the OpenShift community. It's called OpenShift Commons. But it's a lot about cross-collaboration, working with the different ecosystems. There's hundreds of developers that are working and contributing to Origin, that GitHub repo, but we're also doing lots of work in Docker and etcd and Kubernetes and lots of the other toolings that we're bringing in. So there's a lot of people there working it. I mentioned before, we are built on the back of giants and some very small projects too. There's 3 offerings that we have. I run the Origin project, but there's an enterprise on-premise offering, a managed hosted, dedicated one, and OpenShift Online, which I noticed a bunch of you had used before. So it's a pretty big, vibrant community. I really encourage you to come and join us. We're going, how many of you are going to KubeCon in Seattle in the next few weeks? In the beginning of November, all the Kubernetes folks will be there. We're hosting the day before a gathering that I invite you all to join us with, which will go on a lot of deep dives. All the open source project leads will be there. So if you'd like to go, just find me afterwards and we can make sure you can get in. And so I'm just going to speed through some of this because we only got 2 minutes left, 1 minute left. Really what we're talking about here is rising you up from worrying about the infrastructure underneath the hood and letting you focus on the developer workflows and being able to take advantage of the scale and the speed and the efficiency of containers that are available to you these days. And Puppet is a great way to model all of that. And Puppet's been a wonderful member of the OpenShift community for many years, and so we're really pleased to be here. So thank you, Daniel, for inviting us.
Thank you, Diane. Enjoy the rest of PuppetConf.